So now that we know how to add, subtract, multiply, and divide rational functions, the last thing we're going to do with them is solve equations. So a rational equation is an equation that contains one or more rational expressions. So remember, rational expressions have a variable in the denominator. So everything we're going to do today has variables in the denominator. So if we take a look at the first equation that we have here, it says 1 divided by n equals 3 divided by n plus 4. So remember, an equal sign just means the same as. So the stuff on the left is the same as the stuff on the right. We just need to figure out what n is in that situation. So the first way that we're going to do this solving is with cross products. So you've done this before with just plain old numbers. Like if I give you a fraction of 1/2 and I tell you it's equal to the same thing as x divided by 4, hopefully in your head you can figure out 2, but the way that we learned to solve this before was to do some cross multiplication. So you do 1 times 4, which is 4, equals 2 times x. And then if you solve this, divide both sides by 2, you end up with your x value. It should be 2. And you know that 1/2 is the same thing as 2/4. So we can check these, which is awesome. So we're going to do the same thing, the cross products, with these rational functions. You can only do that if you have a fraction on one side and one fraction on the other side. These other ones that we're going to do are not going to have that. And in that case, we're not going to be able to do cross products. So if we want to start with the cross products, we multiply the things that are across from each other. So 1 times n plus 4, and I'm going to show a ridiculous amount of work to begin with, equals n times 3. So we can simplify this very quickly. We get n plus 4 equals 3n. And now this turns into something that we can solve. So get all your n's on one side. And then if we divide both sides by 2, we get n equals 2. Plug it back in. Make sure it works. Running out of room here, but if I do 1 over n, which is 2, it should equal 3 over 2 plus 4, or 6. And 1/2 is definitely the same thing as 3/6. Let's skip B for a second. You guys can try that one on your own. And let's do C together. So we have to do 21 times x, or 21x. And then we have to multiply 3 times x minus 7. So back in this problem, we didn't have to multiply anything together because it was just a 1 on the outside. But when you have something different than 1, you have to remember to distribute. So we should get 21x equals 3x minus 21. And now our goal is to do the exact same thing. We want to get x by itself, so let's combine all of our x's. Subtract 3x from both sides. I get 18x equals negative 21. And then we solve. So if you divide both sides by 18, we get the x equals negative 21 over 18. So kind of a messy fraction, but let's simplify it. A number that goes into 21 and 18 is 3. And it goes into 21 7 times, and it goes into 18 6 times. So we can simplify our answer to negative 7/6. And of course, this could be checked also, but it's a little messier to check. But on a test or a quiz, make sure you do that. Go ahead and pause the video and try 1B on your own. So you should have gotten that h equals 1, and this is an easy one to check. You end up with 4 over 2, which is the same thing as 2 over 1. So let's try some of the harder ones. These ones we cannot do a cross product because it's not one fraction equaling another fraction. In this case, it's 2 fractions added together equals another one. So what we need to do is get our problems to look like the other ones. We need to combine what we can so that we have one fraction plus another fraction. And that's going to allow us to do the cross product. So we're going to start off easy. This first fraction here, 2 over a plus 1, plus 1 over a plus 1 have the same denominator. So that means we can just add across. We really have 2 plus 1 all over a plus 1. Or 3 over a plus 1. Same thing. So now that means that we can rewrite this part right here as one fraction. 3 over a plus 1. And that's exactly the same thing as this guy over here. 4 over a. And now this looks exactly like the problems we've been doing. Do the cross product. So we get 3a. And if I distribute 4 to both of those things on the other side of the equal sign, I have 4a plus 4. If I move my 4a's over, I get negative 1a equals 4, which means that a is negative 4. And we can still check these ones. I suggest you plug it back into the original equation. So plug negative 4 back in here. Equals a. And even though this was pretty messy, we can still check it. So we would end up with 2 divided by negative 4 plus 1 plus 1 over negative 4 plus 1 equals 4 over negative 4. And if you simplify this, you end up with negative 2/3 minus 1/3, which is the same thing as negative 1. So 2b and 2c are both a little messier because we don't have the same denominators. And because these things have different denominators, we know that we're going to use the LCD, the lowest common denominator, and simplify our equation somehow. What we're going to end up doing is multiplying the LCD by every term. And we have 3 terms here. 1, 2, 3. And when we multiply the LCD by each of our 3 terms, we're going to get something to cross off. Then it's going to turn into an equation that we know how to solve. So our first step is find the LCD. Remember, your lowest common denominator needs one of every part. So I come to my first denominator. It has a j plus 2 part. So I need to include that in my LCD. The next part has just a plain old j. So we need one of those. And then finally we need 2j. We already have the j part down because this is 2 times j. So all we need is a 2. So this is our lowest common denominator. It looks messy, but that's what it is. So now we're going to take every term and multiply it by the LCD. So I'm going to use colors to make this make a little more sense. But I'm going to take this fraction right here, 6 divided by j plus 2, and I'm going to multiply it by the entire LCD. And because we are multiplying both sides of the equation by the same number, we can leave it just as j plus 2 times j times 2. We do not need to do the same thing on both the top and the bottom. But that only works when you have an equation. So we can see from this that stuff crosses off. J plus 2 crosses off, and I am only left with this stuff here. So I have 6 times j times 2. So if we totally simplify this red fraction, we end up with 12j. Now just hang on to that for a second because we're going to do the same thing with all of our other fractions. So this next one, we start with a negative 10 divided by j. So multiply by the LCD. which is j plus 2 times j times 2. And again, we see some stuff crossing off. The j's cross off, and we're left with negative 10 times j plus 2 times 2. So let's simplify our numbers. Negative 10 times 2 is negative 20. And then we need to distribute it to the j plus 2. So this blue fraction changes into negative 20j minus 40. We will be able to replace that negative 20j minus 40 with our original, let's change this to blue equation up here. We have one more fraction that we have to do this with. So let's make this one green. I'm going to write it up here. We're kind of running out of room. 4 divided by 2j needs to be multiplied by the LCD, which is j plus 2 times 2 times j. And a couple things cross off here. The 2's cross off, but then also the j's cross off. So I end up with 4 times j plus 2. If we simplify that, we get 4j plus 8. So now let's think back to what we just did. What we did is we took our 3 fractions, multiplied them by the LCD, saw what crossed off, and changed it into an equivalent number. And remember, this only works if it's an equation. So now we need to take all of these things, the 12j, the negative 20j minus 40, and then the 4j plus 8, and we need to set them back up in our equations like we have them. So it's red and blue on one side equals the green stuff. So our equation becomes 12j minus 20j minus 40 equals the green stuff, which was 4j plus 8. So now this is turned into something that we can solve. Combine your like terms over here. And then get everything on one side. So if I want to move my 4j's over, I end up with negative 12j. Add 40 equals 48. And if I divide both sides by negative 12, I end up with j equals negative 4. And just like all the other solving ones, you can take that negative 4, plug it back up into your original equation for j, and you should be able to check it and get the correct answer. So, super confusing. Let's do one more.